Hey y'all, so this is our last video of the unit. We got one more thing to talk about, and it'll actually be useful in the future because we'll have a lot of different vocabulary in order to explain functions and what's going on. So we're gonna talk about some that we've used in our everyday language, maybe make it a little bit more mathematical. And we'll also learn a little bit more about some new terms. So first off, we have increasing and decreasing. We can talk about functions increasing, functions decreasing. And so a function is increasing overall if the output at a second point is greater than the output at a first point, okay? And so that just says that the output of the second point is greater than the first. So we take a look at these two guys, and you'll see that x1, well, even though we dip below, the function is overall increasing between these two places because we have a final point that's higher than the one before. The output is greater than the one before. Good thing to recognize too, my output y, the values on my y-axis, are going to be equal to whatever x value we plug in there, whatever rules it is. We're not focused on it, but just a good thing to know. So in this case, our function is increasing. For decreasing, we can compare this to maybe a third point. Let's say x3 over here. So notice how we're going on a wild ride, but overall, my point for this third point, my output, is less than my output for the first one. So we can say that this function is decreasing between this interval. So f of x3 is actually less than f of x1. So again, the output of the second point is now less than the first. So those are two that we're pretty familiar with. Here are some other important vocab terms. So we have one point right here, one point right here, and one point right here. So we should first look at the just the local maxima or minimum. So if we're looking overall, the local max and mins all this is telling us is where our function, does our function change from increasing to decreasing. Increase to decrease, or vice versa. So we're checking it out here, increasing, 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 and then we hit a top point and we start decreasing. So this would be a local maximum. We are now decreasing, decreasing, decreasing. We can take another turning point, so this is going to be our minimum, our local minimum. We're increasing, 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 and then we have another maximum here. But notice how it's the biggest maximum out of all of these. So if you're looking at the highest point for the entire function or the lowest, you're looking at the global maximum. So global maximum or minimum. So where is the highest or lowest point on our function? So we can take a look at this and notice, well, this is the highest point right here. So this will be our global maximum. One good thing to know about this is that you can either have a global maximum or a global minimum. You can't have both. Because our function either is going to have no turning point or one turning point. If, say for example, we had a little sketch up here of a function like so, this is going to have neither a max or min. Neither global max or min. So whereas you can have multiple local maximum and minima, there's only one specific one specific point where you're going to have your global maximum or your global minimum. In this case, there is none. No global minimum. And so finally, we have concavity. Concavity is our last, so let's see what color should I make this. We have min, max, increasing, decreasing. Let's do blue. So if we're talking about concavity, it's kind of like the curvature. So we can have two concave up or concave down. So concave up is kind of like a bowl. I like to see it as like sitting in a bowl. So it's going to have some sort of steepness where if you were to put a ball inside of it and roll it back and forth, it's going to stay inside. So an example of concave up would be right here. So I'm going to abbreviate it CCU. Next up we have concave down, which I'll make red. So concave down is going to be our umbrella. So it'll generally have curvature that looks like this, kind of upside down. And I'm going to abbreviate it as CCD. If we're looking here, notice how we have kind of a bowl shape or an umbrella shape right here. And we have an umbrella shape right here as well. So these two places are concave down. CCD, CCD. And so we have one more term, and it has to deal with changing concavity. So notice how we go from an umbrella to a bowl to an umbrella. Well, we have these specific points. Let's make them purple. Why not? Or maybe green. Let's make them green. So we have these 2 points right here on our graph. And these 2 points are where we change from concave down to concave up. So we can see the inflection point, this is called, as the point where concavity changes. Or the curvature of your function changes. So this has a lot of great analogs to a lot of physical phenomena. We can talk about speeding up and slowing down in terms of acceleration. We can also talk about it in terms of other applications of physics that you might have actually talked about last year. But I'm going to leave it at this. You have quite a few vocab words to kind of get familiar with. We have an increasing function being the place where overall you are increasing your points. Your points or the outputs are increasing. Decreasing is the opposite. We have our local maximum and minimum, so all our maximum and minimum points, or the turning points. Global maximum and minimum, which you're only going to have one, either the absolute highest point on your function or the absolute lowest. Finally, we have concavity, or is our function curving downwards or curving upwards? And finally, we have the inflection point, which is the changing of our concavity.